Hello friend, this is Umang. In this video, I'm going to explain about my Unix experiment number 8. So in this experiment, we need to play with the process creation. So our aim of this experiment is to write a program to demonstrate parent and the child creation in the Unix. So for creating, so we need to do this task. So we can write that program in C and C++ program. So first we have process A and process B. We need to get some user for seconds and we need to calculate in B and then we need to print our details. So first I am showing my for first one. So G++ for compiling C++ program. Now 3600 I am entering my password. You can see that child process is created and process is this in calculating minute is 60 minute in 3600 and R is 1. And parent process is waiting for some time because I give some sleeping time and then process ID for my parent. Now I'll show you my program actually how I written in this first part. So you can see here for IO stream, this is system using namespace. This is syntax. First, I am declaring in second. Now, first I am taking my second in CN. Now I take it my second. For creating, we need to use process fork. It is for creating the process. Fork is the command for creating the if and this value is return 0 if it is child is created. Now, it child has been created. It is 0 child process and process ID for PID get PID for printing the process ID and then this is method for converting second divided by 16 minute divided by 60 hour and I am printing. If that is greater than what I am selecting or I am giving for 10 second and then parent process and I am printing my parents process that you already see in my program. Now for second one what I need to do, I need to give A and B. A I need to create B and then C. I need to take some input in A and then reverse I need to do in C and check I need to do check in palindrome or not that in my C and I need to print all the process ID and the parent ID. So I'll show you first my program. So you can see in this program, this is syntax first C character array and the variables here. First I am enter character is 1 ending with E. So if it is E that I am given break, so it will break and here and value I am taking. Now I need to do some calculate and minus 1 because array always by default array start with 0 and then see out handle for next line and then for. Now my child is created that is child is B. If it is 0 it means child is B and get process ID I am printing my process ID and now I am printing reverse I and minus 1 to 0 for printing reverse order and that value I am storing in D array and I am printing my cout D. Now I am giving some sleeping time that is 5 and parent process ID I am printing here. Now process ID I am printing here. After that what we are doing parent process ID then get PPID so it will take my parent's ID. Now I am creating again. Now after reaching to A what we need to create one more process that is child process its name we need to give as a C. So for creating again after reaching PPID process ID I am printing for command. If it is returning 0 it means it is my process C has been created. ID is get PID for this is method for getting process ID and then print palindrome. What we are doing, we are I0 to n minus 1 f flag I am giving to 0 and m minus minus 1. If my flag is 1 it means it is a palindrome but otherwise it is not a palindrome. Now I'll show you my C++ experiment 8 a.cpp a.out. Now I need to the correct ending AB I am giving ending with E. Now you can see process ID is B has been created. Reverse is it BA is for ending. Now you can see it is not a palindrome because it is start with B. So it is not a palindrome. Now for third one, I'll give you one more that is palindrome so we can check if palindrome is showing or not. So B A B A A B LPA and PP. Now process ID has been created. Reverse is now you can see After some rest, it's saying yes, it is a palindrome. Now for third one. Now third, what we need to do in third, we need to create A child is B, then C, D, E, F. So B child is D. After reaching B, again we need to for command use same as here. So A need to get some integer, B is finding for factorial. After B, we need to create child that is D is for Fibonacci series. So first I am explaining this part. So you can see here I am getting some number. After that, after taking some number, I am using for command. That is my process B, and process B I am finding factorial F factorial I am using here, and this is my I am using as a function, and factorial is as a function I explaining here. My factorial, if it is n is greater than, I am calling this is recursive n star n minus 1, otherwise return. That value I am returning, and that I am printing my factorial value. Now after factorial, what we need to do, we need to create one more child, that is for command I am using for PID. It means that is a my after B I am using factorial. Now factorial B I am printing. After that I am process, that process name is G. So get PID for its printing, that need to check Fibonacci series. So this is logic for Fibonacci series. If it is a one, returning, otherwise I am using continue for, it is for t plus 1, t equal to 1, t equal to next term, and C out for next term. Now after that we need to reach to my parents. So for that we need to use ppid. Now I reach to my parents. After that I need to create C, then C again for command for E, and ppid for reaching to C, then again for id for reaching E. Now you can see here C, I'm getting my for command, that is process C, that get PID. And this is for logic for finding it is factorial or not. C is used for Armstrong or not, and E is for prime number, and F I need to reverse that number only. So E is for my Armstrong or not. So for Armstrong, what we need to do? We need to check that value is equal to that one or not. Power. So here temp equal to 0. This is logic, temp equal to temp divided by 10 A plus 1 F number. If it is number, I am adding that number. If it is sum equal to that number, I am telling my that is Armstrong number, otherwise that is not Armstrong number. Again I am creating my for command for creating E process for prime number. So that I am doing 2 to number. If is that mode number equal to 0, it is not a prime number, otherwise it is a prime number. And then F is for reverse for that number. What I am doing, my remainder equal to number minus 1, and it is for number into plus reminder into reverse reminder, and reverse for that number. I'll show you my output. G++ for compiling, and here a dot output for printing. I am entering the number. This is 5A. Process has been created. The factorial is 120. Process D has been created. This is the Fibonacci series. You can see after that is reaching to A. Now after that it will create the my process child is C. That is finding it is a strong number. What is single number I am only give it. After that you need to find that prime number. So it is found P is a prime number. Reverse this number is same as it is. I hope you understand this experiment.